This video is going to cover the last part of the MIS Module 2. We're going to talk about servers, operating systems, languages, and object-oriented design. As you prepare to go through this last bit for your review, you might want to look at your study guide and be ready to kind of write some stuff down, or know that we're going to be filling in as kind of like page 3 and 4. So operating systems, application software, computer languages and their generations, and then some object-oriented programming. When we left off, we had just got done talking about the different types of computers. We are going to expect you to know the difference between different types of what we call servers. So servers are basically a large network of computers that are set up to store data and provide different resources and different services. So a few examples, and you probably look in your textbook to look at some more of these, but an example would be like an application server would be where it's a server that holds applications that you can access. So the DMAC Virtual Lab is an example of that, because you can connect into the DMAC Virtual Lab and you can work with all of the applications that are hosted on that server. Database servers are servers that are strictly related to storing databases, and so they're used to access data and to save data and hold data. And so especially large companies, you think of your insurance companies and your financial companies, they have huge amounts of data and huge databases with lots of clients' information that they have to save. So they would have database servers. I'm not going to go through all of these. You should look in your textbook or do some searching and take some notes on some of the different ones. Software, technical definition here, is a programs that run a computer system. And so actually, let me back up there. So we have software that runs a computer system, and then we have application software. So you have system software and you have application software. You guys are most familiar with application software for performing specific tasks like Word, PowerPoint, etc. System software works in the background and takes care of a lot of the tasks behind the scenes. And so you might be familiar with Windows system software. That's called an operating system. And so the operating system provides an interface between a computer and the user. So there's Windows operating system, there's Macintosh operating system, there's a Unix operating system. Those are all different operating systems. It increased computer efficiency because resources are shared, and it also performs repetitive tasks. You don't have to retell the computer how to do a copy and paste every time. It automatically knows how to do that. When you go to File Save, it knows what to do because it's built into those operating systems. So control programs often manage hardware and resources by performing job management, resource allocation, data management, and communication. So the operating systems handle all this stuff kind of behind the scenes. You need to know that the kernel is what we call the supervisory program. So if you ever hear somebody talk about the kernel, that's actually the program that's responsible for controlling all other programs. And so the kernel is in charge. And it's responsible for sending communication back and forth between other parts of the computer. Application software, I already mentioned a few of them, and so they have a few here that they're talking about. Computer languages. The slides are not going to be sufficient here. You're going to need to go back and look in your textbook. But you have, just kind of like you had generations of computers, you have generations of computer languages. Machine language is the lowest level of computer languages. It consists of ones and zeros only, binary. It's dependent on each machine, and it's very time-consuming to write. Assembly language is a second generation of computing, and it's a little bit higher level than machine language, but it's still kind of cryptic. It's also machine dependent, which means it would be different on a Mac than it would be on a Windows machine. It has short codes and mnemonics for representing data, and programs written in assembly are easier to read than machine language. You can Google some examples of assembly. We get to higher level languages, which are called third generation languages, and that's languages that are still machine independent, excuse me. So they're machine independent. They're used for web development, internet applications. They're very easy to read, easy to write. Your C++, your Pascal, your Python, those kinds of things are your higher level languages. And so they're self-documenting because they actually read and speak a lot of times like an English language. Like you might have an if then statement or an if else, or you might have a print or a print line statement. Fourth generation languages, our commands are powerful and easy to learn, and they use macro codes. And so some of these fourth generations are like it's like the next level. It makes it easier for people to grab and put together code. A lot of your drag and drop languages are kind of like a fourth generation. So it uses macro codes because you might have several steps built into a macro code that in a third generation language you had to write out several steps for. Fifth generation languages, 5GLs, use artificial intelligence technologies. And so they're very knowledge based. That would be like your self-driving cars kinds of things. And also your natural language conversion types of things are your fifth generation. You will need to take a look in your book and write down some of the examples that they have for these different generations of languages to prepare yourself for your quiz. Object-oriented design is one of the last topics that we will talk about, and this is a paradigm for programming that is used widely, and so it's called object-oriented programming, and it organizes your programming around the systems of objects. Probably the easiest way to explain it would be in a visual environment if you ever had programmed in Scratch or you've played a game. If you are a character in your game, you think of Minecraft, okay? You have different objects that you can use. You have the person that's doing the mining, you have your pick, you have your axe. Those are all objects. So every single object is defined by what properties it has and what it can do. Okay, like in Minecraft, a pick can, only mine certain things, all right? And so objects in object-oriented programming language are the items that contain both data and procedures. So that's what we mean by its properties and what it can do. The classes are the format of the object and the action it performs. So an object is the actual thing that you work with. A class is the template. So think about another example of object-oriented design. Let's see if they give us an example here or not. Or advantages. So actually, let me talk about the advantages and I'll see if I can give you another example. So advantages of object-oriented design are modularity. So if I write some tasks, if I write some actions for a Minecraft person to use in my template, I can actually borrow that action, whether or not they're using the tool such as a pickaxe or a shovel, and I actually don't know all the tools that are available in Minecraft. But if you have different tools that have similar actions, you can borrow code, or that's what they say, you can borrow a module that's already written. So it makes it easier to write and modify and troubleshoot code. Makes it easier to add new modules. So along the same lines, you can have reuse of code. So I might take something that I wrote for one game and apply it to another game. Or I might take something that I wrote for one application and apply it to another application. And it helps with the problem-solving process because many times when you go to solve a problem, you break it down into smaller components. Each of those smaller components becomes an object, and then you define a format or a template for the object, and that's called a class, and then you actually create your objects. And so the actual objects, your actors in a game, are created from using a template. All the actors have a common template, such as an actor might have, different clothing that they wear, and then they might have different actions that they can perform. So they have a single template they might use, and then as you create different actors, they are the actual objects within the system. So this particular image gives us a overview of object-oriented programming principles. And so a class is a template. You create objects from a class. And the idea that you have everything like stored in a single template is the idea of encapsulation, or part of it. You also have what's called inheritance. All of these topics you don't actually need to know. What is going to be useful for you to know is that there is this thing called object-oriented programming. You want to familiarize yourself with the advantages of it. You want to know that an object is an instance of a class, and you want to know that the class is the template for creating objects. And so the end of the PowerPoint slide is just your summary. You'll have that information on your slides. And I might take this time just to also kind of talk about one more paradigm in object-oriented programming. And I might just use a blank slide on a PowerPoint in order to address that. So that idea of creating an object and the idea that you can reuse and you can have modules would be kind of like this. Let's say that I have a bank account. And so I could create a bank account class that has some generic things in it. And then I could create what we call some subclasses or child classes. And I could create a savings account. And then I could create a checking account, for example, using object-oriented design. So I would have a template for a bank account, and I could create bank accounts, but I could also use everything that I did up here in bank account, I could use in a savings account, and then I could use in a checking account. Each of these different objects would have actions and properties. So like a bank account maybe has an ID number. That would be a property. A bank account you can withdraw from, and a bank account you can have a deposit for. Those are its basic operations. A savings account is going to maybe have an addition to the ID. Like maybe they have an ID number and they follow it by an S for savings. So I use my ID, but then add a little something to it. A savings account will still have an ID number, but then it might have, and you will have withdrawals and deposits, but then it might have interest that you have to calculate. So I can reuse in savings. Actually, I might reuse the ID. I might not add to the ID. But I can, in a savings account, I can borrow all the facets and things from the previous bank account, but then I'm going to add this interest method. And that's an action. So calculating or adding interest. A checking account has all kinds of other fees that might go with it. So I can use withdrawal and deposit in the checking account. I can use withdrawal and deposit in the savings account. So that's my code reuse. I can use the ID number in savings and the ID in checking, but then these other things will have additional actions that go along with it. So when they talk about the fact that you can do code reuse, that's the idea that you are building a generic object, and then you can build more specific objects as you work your way into additional needs in your programming. That's going to wrap up these slides. So read through the summary. You do need to look at your textbook to fill out some of the information on your study guide. And at the end of your study guide are some hints about definition of vocabulary that you need to know the difference between, and know the difference, or these are vocabulary that you should know. So go back and use your textbook or use a video to kind of look up some of the differences between them to get prepared for your quiz. Good luck.